In section 3.2, number 55, we're looking for the area of a sector. A water sprinkler is set to shoot a stream of water at a distance. So here's our water sprinkler guy. And it sprays water 12 meters and rotates through an angle of 40 degrees. So we have this, we're looking for this, the area of that sector. I know it's not a great circle. So our area for a sector formula. Oh, I'm sorry, I should read the question first. What is the area of the lawn it waters? So that's our sector there. That's A. And B says for R equal 12, what angle is required to water twice as much area? Okay, so let's start with, looks like I have to go get the rest of C. So for part A, we're looking at the area of that sector. A equals 1/2 R squared times theta in radians. I have degrees, so I need to change that 40 degrees to radians by multiplying by the conversion factor of pi over 180 degrees, which gives me, let's see here, divide both of these by 20, I get 2 and 9. Okay, so that gives me 2 pi over 9 radians. So area equals 1/2. R is the 12 squared.
Yes.
The radians is 2 pi over 9. So that gives me half of 144 times 2 pi over 9. My 2's will cancel when I multiply those. So I'm left with 144 pi over 9. I'm thinking 9 actually goes into 144. So kind of jumped the gun on that one. Yes, 16 times. So I can reduce this guy to 16 and 1. And now I am left with 16 pi for part A, which we can use a calculator to estimate that to match the back of the book, which is 16 times pi, which is approximately 50.3 meters squared. Okay, now going on to part B. We'll do that in purple. In section B, we're going to, part B, for the radius equal to 12, what angle is required to water twice as much area? So I want the area to be 2 times that, or 2 times 16 pi, because I already found that 16 pi in the previous question. So 32 pi. So I'm going to let my area be 32 pi equal 1/2 R squared, I'm still given is 12. And theta is what I want to find. I want to know what the theta is going to be to have it twice as big. Twice as much area. All right. So then I get, let's see here. 32 pi equals 144 divided by 2. I'm going to multiply both sides by the reciprocal of that. Actually, I'll just reduce it. So that's 72. So that gives me 32 pi equals 72 theta. To get theta by itself, divide both sides by 72. And I get theta equals, let's see, I can take a factor of 8 out of each of those, and I get 32 divided by 8 gives me 4. 72 divided by 8 gives me 9. So I'm left with, whoops, 4 pi over 9. That's in radians, and I think it asked us for degrees. So changing that to degrees would be 4 pi over 9 times 180 degrees over pi. My 9 cancels with 180. And my pi's cancel. And I get 80 degrees. So radians and degrees. I'm going to scroll up and see which one I'm supposed to get. Let's see here. What angle is required? It just says what angle. So I was thinking degrees just because our original question was asked in degrees. So you usually want to be consistent with how it was originally asked. All right, let's see. What's part C? I have to go fetch that. Okay, part C asks us to find out, we're going to fix the angle at 40 degrees this time and say what range of water stream is required. So we're looking for the new radius to water twice as much area. So in B we changed the angle, and in C we changed the radius. Okay, so I want to do the same idea though. So I'm going to go ahead and do it next to it so we can see it side by side. So for C, I do, the area is twice as much area, so that's 32 pi again. And I have, the radius is the thing I don't know, so I'll say r squared, and theta is 80 degrees this time. Wait, I'm sorry, 40 degrees. 40 degrees, which we found up above in radians is 2 pi over 9. Okay, so solving for r, these twos will cancel, and I'm left with, on the right I have r squared pi over 9, and on the left I have 32 pi. If I multiply by the reciprocal of pi over 9, so 9 over pi on both sides, then my 9's will cancel, my pi's will cancel on the right hand side, and I'm left with just r squared. Those two cancel and these two cancel. And on the left I get my pi's cancel, and I get 9 times 32. That's some big number. 288. And r will be the square root of that. Let's see, what is the square root of 288? Let's see. That breaks into 144, 12, and 12. So we got 12 squared. We can take that out of the square root, and we're left with a 2. And this is in meters. And to estimate that decimal, we can get 12 times radical 2. And I get that r is approximately equal to 17 meters.